First of all, really thank you, Klaas, for organizing this great conference. That's it. Thanks. Yeah, I'm Philipp. I'm from Wooga. I'm the CTO and one of the founders of Wooga. And yeah, I have these two talks today. I was unfortunately not able to talk to Tim. He's unfortunately sick, so I'm going to take over his talk. So excuse me if I don't know all the nitty-gritty details about what I'm going to talk about. But I know basically how it works and what we use it for. Actually, Kafka is a great system. Kafka is basically the core of our business intelligence platform. And that's why I'm going to talk about it first. And basically, I'll tell you a little bit about what Kafka is, what it can do, and then kind of a use case or case study, how we use it, what we are doing with it. And in the second talk in the afternoon, I will talk about, like, on top of Kafka, we have a couple of database appliances. And we had MySQL and how we went into bottlenecks with MySQL and how we had to replace it and what we replaced it for. That's what I will tell you about in the afternoon. Kafka now. Unfortunately, don't know the joke Tim's always doing here, so I'm sticking to Kafka intro. You know, it's like a German, whatever, philosopher. But actually, Kafka is a distributed publish-subscribe messaging system, which was originally developed, or is still maintained and developed by LinkedIn. You know, this business contact platform. And they use it for their event streaming, and we use it as well. And they open source it. It's by now Apache project, so maintained by the Apache Foundation. And four features of it are worth mentioning, or like describing it, telling you how it's working. It's basically high throughput, persistent, publish, subscribe messaging. Now you know everything. Now we'll go through the individual points, and I will tell you. Check out the watch so I don't lose track of the time. I'll tell you what do we mean with all these points. First one is messaging. Kafka system has a broker, which is the actual thing you have to implement in your platform. And you have producers who put stuff into Kafka. Kafka is basically a big queue. No? You can basically imagine it as a big queue. I'll show you a little bit more about the queue features in a second. But you have producers who put stuff into it. In our case, these are games. Each of our games puts their interesting data into Kafka as a producer, and you have on the other side consumers who take out information they would like to know. And we have a lot of different consumers. Now we have from MySQL to Amazon S3 to a couple more. I'll tell you a couple more examples later on. But that's the basic architecture. You have in the middle the Kafka machine, and you have stuff going in, stuff going out. Publish subscribe is a pretty interesting feature, important feature about it. Kafka splits the data you put into it into different topics, and for us topics are games again. So you can subscribe only to certain topics, and if you publish something, it's already organized into certain topics. Makes it helpful if you have a lot of different content, like when you do games. Now you have a lot of different games. So some people can subscribe to games that are more interesting, other games don't run that well, so nobody cares about the data. You don't have to subscribe to it. Persistency, very nice feature about it too. As I said, Kafka is basically like a queue, so you put data in, but not unlike usual queues, where you can only take it out once, and where you have to take it out right away, where you have to listen constantly. Kafka has a persistency model. So I can go back in time. Right now, we store about 30 days of all of our data in Kafka, or 15, I'm not 100% sure. So you can go back in time and subscribe to older data and get that older data out. And if it breaks down, you still have your data. If your consumer dies because some import didn't work, you can go back and get the data out of it. Pretty helpful feature about Kafka. High throughput. I'm actually pretty amazed. We put right now around 150 gigabytes per day into Kafka, and we have the last 15 days, and it's one server. It's not like a huge cluster or whatever, but it's like one server that's all running, and if you check load memory consumption, it's basically idle. Which is pretty well designed. Now how they do it, don't ask me what Tim tells you here, but it's basically but it's working pretty well, that's pretty good in terms of performance. We will have a couple people who can tell you better, I think. You know how that works better than I do?
You can segments.
You can ask him later on. Knut's sitting there, he can tell you how that works.
How much data is it today?
Sorry?
How much data is it today?
About 150 gigabytes.
Okay, once.
Yeah, and it's like, I mean, the interesting thing is we use serial ATA drives. No, it's not that we beat it up with hardware and have like super high, whatever, Fusion IO or like put it all in memory or whatever. It's just a serial ATA hard disk below. Okay, in the RAID system, but that's it.
Is that 150 gigabytes for the 15 days or for each day?
No, for each day. Each day goes in and basically out on the other side as well. That's basically our look. Now what do we do with it and how do we use it? A little bit more of the details around that one. One thing we love at Wooga, for example, is daily reports. Well, we love to have it in the morning, which gives you an overview over your main KPIs you have in your game yesterday, like your daily active users, your new users, and stuff like that. It goes on, you have bookings as well and other fancy stuff. So this is like an email I love to have early in the morning in my inbox so I can check what was going on yesterday. And that's, for example, built on top of Kafka. There are like more stuff built on top, but this is one example. Maybe we're taking one step back. How does our architecture look like? We have a strict separation between our client, our game client, our servers, or the backend, which is holding the scores and all your, like, I don't know, your garden, whatever, and our tracking infrastructure. So there is no overlap in terms of data. No tracking or reporting stuff will ever access the server itself, and the game client will never take down or load anything from the tracking database, which helps us or allows us to optimize tracking completely on like big data and never like on a single user access, while we can optimize our servers on this single user access, because you will never make like a bigger select. I mean, there are a couple of exceptions, but basically you can optimize the server for gameplay and we can optimize tracking for tracking. So, yeah, I told you, we have the different, we have the internet, we have the different games, they all push their stuff into Kafka. And this is one example. We have a couple of examples. No, I guess this is just our like distribution over days. Of course, I mean, you have more. Actually, even though we have our games pretty internationally, so we have a pretty big user base in the US, you still see usually a peak around 10 in the evening, because that's when the Americans get active and the Europeans are still active. That's usually how our traffic curve looks like. So it's not flat, it's like.
So this time is not normalized, is it like European Standard Time?
That's, I think that's even GMT. But that's a good call.
Yeah, it's GMT.
It's GMT? No. Oh, experts. This is, sorry for like the structure being a little bit like jumpy, but very interesting point as well. I told you it's like one server here on Kafka. Now if you run business intelligence platform or anything, you actually don't want one server. Now the problem with one server is it goes down, your platform is down. Now not the preferred solution. You can run Kafka in a clustered environment using Zookeeper to administer that. So far, we have not implemented that because one server was fine, and with Zookeeper adds kind of some complexity. We just didn't have the resources and time yet to invest into it. So what we did is, we just put a second Kafka next to the first Kafka and rsync all the data via just rsync. Now, rsync is just copying basically. And keep it on standby. So if this one breaks down, we quickly have to log in here and switch all the producers to the other one. That's basically our failover mechanism. Not the most elegant automated system you can imagine, but better than nothing is what we thought. No? And pretty simple to set up. Maybe one day we will implement that Zookeeper solution with like distributed stuff as well. But so far that's our fallback when it breaks down.
Have you ever seen crash in Kafka so far?
No. Actually, no.
So it just runs stable for...
Yeah, I'm pretty amazed because most things crash down from time to time. We have it like, I don't think, we have it like a year maybe, like more or less a year we have it running as far as I know. And so far, no. I mean, it doesn't have a lot of load, now that helps. Because, I mean, how it works, I mean, what it's using is basically you're very like sequentially putting data into it and taking it out. You don't have any random access. That's why like the load is so low. Now that's how basically it works out the trick, why it can scale so easily. And I guess the low load helps to keep the system more stable. No? If you run a CPU at max for a year, you have a higher chance of getting stuff. Here we have a couple of examples of what we have on top of Kafka. We have, for example, our MySQL database. That's basically the main use case, or like what I will talk about later on, like how this one like scaled and what else there is. But it's basically our SQL database. We put it all in SQL. On SQL, you can put some queries aggregated, put it then on a web front end and a daily report and other stuff. But we have some fancy or interesting use cases as well. For example, S3, which we take as our backup. We put all the data there, so we have kind of a backup. And we can never like lose any data. The interesting thing is actually we put on S3 on top, you can use this elastic Hadoop solution, and you have your Hadoop cluster without really doing a lot. We have Librato, that's the source of these fancy graphs. And there we just have a consumer who consumes the data, but who's not doing more than just counting the amount of certain events in the last 60 seconds. And then it's showing it away and displaying it here. So here, this is for example all of our different games, and the install is per minute. So that's kind of a use case which is not really very much data related, because you just sum up the last 60 minutes and you can do something like fancy real-time graphs pretty cheaply with the system. So nice use case. And we have a couple more. We have, for example, something like Nanigans, our advertising partner. We use a partner who's managing all our advertising on Facebook. And all payment events, we have a consumer who's only listening to payment events, and these payment events we push to them. So they can know for their advertising customers what revenue they made, and they can optimize the advertising based on that one. Yeah, these are examples for it. And last interesting point, Kafka-esque, because if you want to write all these consumers and consume data, you want to like do that as simple as possible, no? Preferably, because Kafka has a protocol which is not super complex, but still is kind of low level. No? It's like, and if you want to program your consumer in Wooga or something, you don't really want to mess around on like HTTP level. So we have this Kafka-esque gem, which is encapsulating the Kafka interface for you, which makes it pretty simple to build one of these fetchers or consumers. What's that? Here. Looks basically like this. You know, if you just want to start a new consumer, if you're in Ruby, you basically put your host, your Kafka IP in here. You mention the topics you want to subscribe to, which is here basically a constant where you can define the games you want to listen to. And you make .start, and there you go. And from there on, you have your stream basically in Ruby. You can directly work on it. This is the gem. It has a couple of additional features. For example, it directly converts the time into an object. It has some, we open sourced it, so if you want to use it, you can use it as well. There are a couple of additional features we took out of the open source world because they're not that interesting. Not calculating bookings out of money, because you have to deduct sales tax and you have to take away the Facebook share, and like, it's not secret, but it's like nothing anyone else needs. But apart from that, it's basically like this in the internet. Our internet link is on the next one. Yeah, but Kafka-esque is kind of what we use on top of Kafka to access all the data. Now, this is too much for me. Skip through that one quickly. But if you want to have a look at it, you find it at GitHub under our account, our Wooga account. I think, yeah, that's Kafka. That's what Kafka, what we have, what we use it for. Any more questions? You already asked a couple ones, but you have some more questions about it?
Your chance.
Your chance.
How about the load? You said that at the moment you process about 150 gigabytes per day. Do you have any expectations on how much could be processed in total?
I mean, LinkedIn is writing some things on their website about, I think it's 100,000 messages per second is something which you can handle. So it's really, I mean, LinkedIn is a pretty big platform now, and they have like a lot of stuff they're streaming in and out. Oh, that was good. Yeah, but in terms of that, and you can cluster it. Okay. So far, I mean, I tell all of the game teams, don't be shy, not spam as much as you want, because we can handle it, and we can, like, good thing is you can decide on consumer level what you really want to take out of it, because of course all your like MySQL and whatever data will break down, whatever you take if you spam them with a terabyte per day, because it's just well, it's just too expensive. But
yeah. Okay, so there are a couple of other approaches for doing that. So for example, RabbitMQ or ZeroMQ. Did you also try these, or was there a particular reason for switching to Kafka?
Well, RabbitMQ, I mean, I'm not an expert at it, but as far as I know, of these features I mentioned in the beginning, like persistency and so on, RabbitMQ only has half one. It doesn't really, as far as I know, doesn't have the persistency. You can't really go back in time. You don't have the publish-subscriber model, as far as I know. And these are all features we use pretty heavily.
Okay. So persistency.
No, there's persistency.
Okay.
Maybe not.
Yeah.
I think, I mean, we looked at it, but we looked at it and we had a feeling that Kafka fits our needs best in what we want to do. But usually, I mean, there are like several solutions for a given problem. No, I mean, it's not like, but we thought this one fits our needs pretty well. Great. Thank you.
More questions now? Okay. Too fast. Unbelievable.